This is video 4 for lesson 2 in unit 9, weak acids and bases. So this is our last example problem, and this one we're given the least amount of information. So we're calculating percent ionization for 0.100 molar acetic acid. So that's our HA. And we're just going to add pH into this because we might as well. So we know that we can use our generic acid equation. And the only piece of information we have is 0.100 molar HA. So this is probably about as complicated as these ice charts get here. They pretty much all look the same. But in this one, we're not given a Ka. So if you're not given a Ka, then you can look it up on our chart. So acetic acid is right here, and it's 1.8 times 10 to the negative fifth. So that value is equal to x times x all over 0.100 minus x. So now we have to look and see if we're safe to assume. So remember, our ideal is our HA value, 0.100, and our Ka, 1.8 times 10 to the negative fifth, have to be 4 or more place values apart. This is times 10 to the minus first to the minus fifth. We are 4 apart. We are safe to assume. So we get 1.85 times, or 1.8 times 10 to the negative fifth is equal to x squared over 0.100. So we get x is equal to 1.34 times 10 to the negative third. So our H3O plus concentration, 1.34 times 10 to the minus third molar, that we can use to find pH, because we know pH is equal to the negative log of that number. So we get a pH of 2.87. So there's one of our answers. Now we can find the percent ionization. It's our H3O plus concentration over our original amount times 100, and that gives us 1.34% ionized. So with all of these problems, we have calculated these for acids, but they also work for bases. So with these, if we have a base, the general equation is as follows. The base plus water gives us the conjugate acid and conjugate base. So this is what we would use if we had a base, but be careful, because if you're asked for pH, remember that you have to go from POH to pH. So this might have an extra step in it in these problems.